Okay, so this part of the lesson in electron configuration is incredibly easy so long as you're comfortable with working on the periodic table and getting your electron configurations from there. Because this is the same exact process, except it's just slightly shorter. So, what noble gas configuration is basically just condensing down the formulas for a lot of different electron configurations of elements. Because electron configuration is an overall easy task. However, it can get quite cumbersome once you go down to like the sixth or seventh row and you're writing 1.5 billion sublevels. So, what we do is, for noble gas configuration, we first look at the noble gases, which are group 18, or the last column on the periodic table. So we have helium, neon, argon, krypton, xenon, and radon. Now, an important thing to note about all of these noble gases is if you actually write them out, they essentially completely occupy every single orbital or every sublevel that they have access to. So if I was to just really quickly write down the electron configuration for neon, it'd be 1s2, 2s2, 2p6. As you can see, it completely occupies the first two energy levels. Same thing for argon. If I was to do argon, it'd be 1s2, 2s2, 2p6, 3s2, 3p6. And you're going to see this exact pattern keep on going, where every single sublevel that these have access to will be completely occupied. And so what we do is we take note of this and we essentially use the noble gases to condense a lot of the information. So for something like, let's say, helium, which is 1s2 and occupies the very first energy level, you can use helium as a different starting point. So instead of starting at the 1s2 sublevel like we do with copper, which has an electron configuration of 1s2, 2s2, 2p2, you can substitute in that 1s sublevel for helium. Putting the noble gas in brackets is basically saying that this is occupying the 1s2 sublevel, and then you carry on from there. Now, this doesn't look that impressive right off the bat, but if we run through some examples of noble gas configurations, and as we go down the periodic table, we'll see how much more important this can get. So, before I run through a noble gas configuration, let me just go ahead and write the electron configuration for something pretty simple, like magnesium. So if you were to write the electron configuration for magnesium, you'd get that it's 1s2, 2s2, 2p6, and 3s2. It stops at the 3s sublevel right here. Now, what you can do is, instead of writing this entire section, 1s2, 2s2, 2p6, you can instead start at the noble gas that goes before magnesium. If you don't know how to find the noble gas that goes before magnesium, you just go up one row and all the way to the right, and we reach neon. The reason why we can do this is because neon's electron configuration basically fills up the first two energy levels, or it goes 1s2, 2s2, 2p6. So instead of writing all of these three sublevels at the very beginning, we can instead just put neon in brackets and then just carry on from there. So then the energy level after neon would be the third one, and this is 3s, and magnesium puts 2 electrons there. As you can see, this is a pretty slightly shorter way of writing down the electron configuration for magnesium. We've trimmed down a lot of the fat. So let's go ahead and look at some more examples. Let's go a little bit lower on the periodic table. So let's say we're going to work with titanium, Ti. Now, Ti, you would have to first fill up the first energy level, second energy level, third energy level, and then reach the fourth energy level. So you'd have 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d10. However, what's easier is to just start at the noble gas that goes before. So we're going to go up one row and then all the way to the right to reach argon. So argon is going to be my new starting point. So instead of writing or starting at 1s, I will just put argon and then continue from there. So after argon, you can see that we hit the fourth row. This is going to be 4s2. And then we reach 3d, 1, 2 for titanium. So the noble gas configuration for for titanium is argon 4s2 3d10. We can go ahead and work on a couple more examples. So let's go even lower on the periodic table. So let's say we were working with tin, Sn. Tin, if you wanted to do it the regular way, you would have to first occupy the first four sublevels, first four energy levels, and then you would finally reach the fifth one, which is where tin is located. But instead, you can just start at krypton. So, to start off the noble gas configuration for tin, you'd write the formula for krypton in brackets. This basically constitutes the first four energy levels, and then you just move on from there. So this will be 5s2, then 4d10, and then lastly 5p12 in the case of tin. And we can do one more. We can have some fun and use the F sublevel. So let's go ahead and do the noble gas configuration for lead, which is Pb. Again, for lead, it's in the 6th row, and typically we would start at 1s and then work our way down, but we can easily just skip the first 5 energy levels by starting at xenon. So the noble gas configuration for lead will be xenon, and then you just pick up where xenon leaves off. So this will be 6s2. When you reach this block right here, this is 57 through 71, which is this entire section right here, or the 4F sublevel. We know that it's going to be completely occupied, so we can just write 4F14. Once you're done with these elements, you now move on to these right here, which is the D sublevel. This is going to be 5D, and we know that it's completely occupied, so it'll be 5D10. And then finally, we reach the section where lead ends up being finished off. So this is going to be 6p, and then lead puts in 2 electrons, 6p2. So again, noble gas configuration is the same exact thing as your regular shorthand notation. The only difference is you just pick a different starting point to shorten a lot of the excess work. So this is mainly useful for elements that are really, really low on the periodic table. Okay. Again, you can do the same thing that you did with electron configuration, which is just point at a random element and just work out the noble gas configuration, and that's plenty of good practice. Right? That'll do it for this lesson, and good luck studying.